see that. We got 3 questions, kind of reviewing a few of the basics that we've discussed already. Shouldn't take very long at all. I'll zoom in so you guys can see it a little bit better that are sitting in the back. But these 3 questions, we're going to be making use of the topics covered in here during today's lesson about solving equations that have radicals in them. So take you about a minute or 2, and y'all move through these questions. Wonder where Ben Ralphs is today. Anybody heard from him? Did you guys ride with him? He's got a different schedule then. Okay, I forgot. Thank you, Quinn. About 30 more seconds. As you're working through these, you might note that our text, I just pulled these from the text, makes mention of the sections that they're found in. So like section 5.3, 2.2, and 6.4 respectively is where these 3 topics come up. Okay, so Alex, let's start with you on number 1. What do I do to a problem like this? How do I simplify a binomial squared? That a boy, very good. We're gonna it's a FOIL problem. The temptation is to say what? Just square the first term, square the last term. No, no, no. Remember, that's a swift kick to the gonads for sure. Instead, we're going to say y minus 3 times y minus 3. Alex, when you did that, what'd you get? Oh, let's do it in real time then. I'll walk you, or rather, you'll walk me through it. Do first times first. Okay, the outer 2. No, when I say the outer 2, you got y and negative 3. And then the inner 2, that's going to combine to give you perfect. And then the last times the last will give you plus 9. All right, so that's just exactly like Alex said. It's a FOIL problem, and squaring out a binomial is what we want to do there in that example. All right, number 2, it's almost so easy I hesitate to ask, but Drew Benton, go ahead and tell us what to do. 2 steps. So we get 5 halves. Okay, fabulous. Now, number 3 is the problem. Paul, go ahead as you cover up. Yeah, I'd take 2.5. And then since your hand's up, tit for tat, you answered or you asked a question, now you got to answer a question. What do I do on number 3? About a problem like number 3 is a quadratic equation. How many answers am I going to be looking for? I'm going to be looking for 2 answers. And my first step right out of the gate should be to what? Louder. How about n minus 4 and n minus 2? And Tiago, what does that mean my 2 answers or my 2 roots or zeros would be in this case? Very good. And that's using factoring in the ZPP. That's the only way so far that I've taught you guys how to solve a quadratic equation. Every quadratic equation that you guys have encountered up to this point in the school year has been factorable and therefore ZPP-able, if I could say it that way. Okay? All right, so any questions on this quick little warm-up? We're going to be using these skills today. All right. Now, you look at kind of what we're going to be doing as far as the bullet points for this lesson or this section. Obviously, going to be solving some radical equations. Some of them will have one radical, some of them will have two radicals. I'm going to give you a step-by-step approach. I think a lot of times you guys like it when we have a step-by-step approach to solving. And then we'll see some word problems that have radicals in them. All right, so here's your step-by-step approach, okay? The first step is to get the radical by itself. Okay, write that down. Get the radical by itself right out the gate. Okay? In an equation like this, there's one and only one radical. Bless you. So to get it by itself, Charlie, what would I do to both sides? Yeah, very good. We got square root of 5n minus 4 equals 0 plus 9 is 9. So we added 9 to both sides. Okay? The second step, we're going to use an inverse operation. Joe, what's the inverse operation of a square root? An exponent of 2. In other words, we're going to square both sides when it's a square root. James, if it's a cube root, we're going to cube both sides, right? If it's a fourth or fifth or sixth root, we'd raise both sides to the fourth or fifth or sixth power, respectively, okay? Step 2 says raise both sides of the equation to the power of the index. Remember that word, that vocabulary word index just means what number is sitting on the little ledge right up there. And there's an implied 2, so that's where we get that answer to this question. Hey, what do I do to both sides? I'm going to square both sides. All right, so step 1, we got the radical by itself. Step 2, I'm going to square both sides. All right. So I've got, oh, by the way, when you square a square root, what happens? Does the world explode? Yeah, very good, Quentin. You just take away the square root, son. You got 5n minus 4 equals, don't you dare say 3. 81, good. Then lastly, it says solve the new equation. Okay, I can do that. Add 4. Divide by 5. Ooh, what's 85 divided by 5? 13? I feel like 13. 17. Oh, I was way off. Thank you, guys. And then look at step number 4. Why is step number 4 important? It says check the answer. What might be rearing its ugly head? James? Plug it in to make sure it works. 17 times 5 is 85, as y'all tell me. 85 minus 4 is 81. Square root of 81 is 9. 9 minus 9 is 0, so it checks out. What if it didn't check out? What kind of solution would 17 be? Luke? An extraneous solution. And fellas, we've got to be on the lookout for extraneous solutions when we're dealing with square roots in equations. Make a special note to that effect, okay? Reason being, square roots have some implied domain restrictions on them. For example, you're not allowed to take the square root of a negative number, okay? And therefore, once in a while, I might get a solution that when plugged in makes the radicand negative, and therefore it is extraneous. Okay, so we got to not skip step number 4. Step number 4, I put a little star by it because it's a skip that a lot of people step. It's a step that a lot of people skip, pardon me. And as such, it's room for mistakes. All right, here's one for you guys to try. The square root of 10z plus 1 minus 2 equals 0. Go through all 4 steps. 1, 2, 3, 4. See how you guys do. Joey, is your microphone working? John Zweig, what about you, bud? You got a microphone that works?
Yes, sir.
Speak up, John.
Yes, sir.
Attaboy. Okay, I can hear you. All right, John, tell me what do I do first here? What's my first step right out of the gate?
Add 2 to both sides.
All right, good. So I got 10z plus 1 equals 2. And then the next step will be?
Square both sides.
So I got 10z plus 1 equals 4. And then take me home. Go ahead and run it. You got 2 more steps.
I subtracted 1 from both sides.
And
divided by 10.
Very good, very good. So we got 3/10. And when we plug that in, it's not an extraneous solution. We get a true statement. We get 0 on the left, 0 on the right. Well done, John. Thank you. Now, these are easy enough. Okay, these are basic. These are like A-level questions that you'd see in a textbook, right? No curveballs, no tricks, no nothing. Okay. But once in a while, we see a slight curveball, a teensy, tiny little curveball. And in this case, you need to be able to recognize the curveball. We had some guys, we're in season right now with baseball, early season, but still in the season. So we're having some guys throw live to hitters. Okay, so we have some pitchers that are throwing live to hitters. And so Saturday is pouring down rain, just rain. So we're inside hitting. And a couple of these guys have some pretty good little breaking balls. And the hitters, right now, early in the season, you guys know this about baseball, early in the season, the hitters are typically behind, right? The pitchers are usually ahead. And so the hitters are coming around, they're working. But anyway, we had some kids breaking off some pretty sick, nasty little deuces. And the boys were just out in front. Out in front on a curveball is a bad recipe. You got to stay back to hit it. And so in this case, right here, we got a little curveball. We need to be able to recognize that quote pitch that's coming our way, okay, so that we can stay back and adjust and hit it. When I do that first step, just like John Zweig did in the last step, in this case, when I subtract 2 from both sides, square root of 3x plus 7 equals -2. Right now, if I recognize that there's a curveball, I can be more successful in my approach to this problem. What is the issue here? Why did I just write something weird on the screen? Because the square root of a number is non-negative. We said that day number 1 when we started this section on radicals, this chapter. The square root is defined as a non-negative number. And yet, I've got an equation that says otherwise. So this equation is hogwash, balderdash. Okay? It is nonsense. There's no such number that I could plug in here to make the denominator, to make the radical equal a negative number. So we're going to say no solution here. However, let's pretend like you're like some of my JV hitters, okay? You're out front. You did not recognize that the curveball's coming, and yet now the curveball is upon you. What do? You're just going to stand there like a goober with his knees buckled, or are you going to try and fight it off, foul it off, and get another pitch, okay? So like, let's say I didn't recognize that this was a special case, and I'm just like, monkey see, monkey do, monkey poop all over you. I'm going to go through my step-by-step process. What's step number 2? Square both sides. Okay, great. So when I square both sides, I get 3x plus 7, because the square root goes away. The right-hand side goes to 4. Subtract 7, I got -3. Everything's looking great, man. Everything's looking gravy. X equals -1. What is my saving grace going to be? Tiago? When I dadgum plug it in. Because right now, if I boxed this answer and said, "Dunzo, problem's over, thank you," I'd be wrong because I didn't check for the extraneous solution. X equals -1 is an extraneous solution here. I'll show you why. If I plug it in, 3 times -1 plus 7 plus 2, and I say, does that equal 0? The answer would be no. 3 times -1, 3. Excuse me, -3. -3 plus 7, 4. Square root of 4, 2. 2 plus 2, last time I checked, does not equal 0. That's the problem. So that's an extraneous solution, and we would therefore say this problem has no solution. Okay, that's why it's a special case. You guys see what I'm talking about there? And that's easy enough. After a few of these, after you practice a little bit, I mean, it'll be like a JV curveball, right? What happens if I get one of our good varsity hitters to stand in there on a JV pitcher that's throwing curveballs? He's going to look at that curveball, he's going to recognize it, and he's going to hit it. That's what you guys will do. Y'all will recognize, and you will hit it. All right, in this example, we're going to up it just a little bit. This moves from an A-level example to what I would call like a B-level example, if you will. Okay? The difference being here is that the right-hand side now, when I isolate the square root, is not going to be just one little term, one little monomial, right? I'm going to subtract 1 from both sides. I'm going to get p minus 1. And then when I square both sides, this goes to Alex Cano's warm-up question, right? When I square both sides, the left-hand side, the squaring of the square root goes away, so I just got p minus 1. The right-hand side is a, what did we say in the warm-ups? Say it again, I was talking. It's a FOIL problem, yeah. It's a FOIL problem. Now, hopefully, you guys are up to snuff on this, that you can FOIL in your head at this point, especially when it's squaring a binomial. Can you guys do that? You get p squared minus 2p plus 1. Okay. Now, Drew Benton, how many solutions is that equation going to have? Why? You're right. Don't doubt yourself. Just tell me why. Because it's a quadratic equation. Now, it's a quadratic equation in blue, but what was the original equation? Was the original equation quadratic? The original equation was just some random equation that had some square roots involved. Okay? And therefore, fundamental theorem of algebra is off the table. In other words, I don't necessarily have to have 2 solutions for that equation up there in black. The equation in blue is absolutely going to have 2 equations, but we're going to check both of them to see if either or both is extraneous, because there's no guarantee with the black equation. All right. So combine some like terms. Let's subtract 1p and add 1. So we'll get p squared minus 3p plus 2. Okay. Mossy, factor that for us. I'll zoom in. I know I've got my big old heads in the way. Factor that out for us. Let's say p minus 1 and p minus 2. Sorry, I put them in the wrong order that you had them in. But yeah, good. We 2 factors of positive 2 that add up to negative 3. And therefore, my answers to this quadratic equation are going to be p equals 2 or p equals 1. Now's where I want to go back and double check for the extraneous solution. Okay? So let's plug in the first one. We got room. Square root of 2 minus 1 plus 1, does that equal 2? All right, 2 minus 1 is 1. Square root of 1 plus 1 does in fact equal 2, so that checks out. Let's check the second example. Square root of 1 minus 1 plus 1 equals 1. Let's see if that equals 1. 1 minus 1 is 0, so we got 0 plus 1 does in fact equal 1. So both of those answers survive. They're both legit, they're both good. Okay, that's just simple step 1, 2, 3, and 4. And then we're relying, so like when I was talking like about with Alex foiling that out and Mossy factoring and using the ZPP, these are the basics that we talked about in the warm-up, right? And these are basics that you guys have been learning about for the last several months, okay? So in blue, what we have been doing, this step-by-step process, is really nothing new, okay? Nothing new at all. You're just putting into action some of the skills that you guys have been practicing. And again, I got the reminder up here, don't get a swift kick to the gonads. Don't mistakenly think in the heat of the moment, right, when you're working a problem on a test and your head's not straight, don't just square this binomial by saying, oh, I'll square the first term, square the last term. Don't do that. All right? Don't do that. Now, for time's sake, we're going to skip that next example. We're going to go on down to example 6. So I'm going to run out of time if I don't. Okay? Now, I say caution on this one, and I'm going to let it ride. I'm going to let you guys try this one on your own. How many of y'all think I just tore off over there? Quick, give me a guess. 23? 17? Anybody else? 35. 35. They ran a neat social experiment one time as you're finishing this problem. Keep working while I'm talking. And they took a jar, I say they, some research mathematicians, took a jar and filled it with, a couple of thousand jelly beans, okay? Multicolored jelly beans, huge jar. It was some random number like 2,417, okay? Jelly beans. And they put it on a table and they brought in people to guess how many jelly beans there were, all right? They just brought in random people off the streets of New York, let's say, and they had hundreds and hundreds and hundreds and hundreds of people come through this place and just say, hey, quick, how many jelly beans are in there? And they recorded all of their guesses. Some of the guesses were good, some of the guesses were bad, but an interesting thing happened. And this phenomenon is known as the wisdom of the crowd. Research mathematicians, they averaged everybody's guesses. It was spot on. It was like within 0.5% of being right on the number, which was just mind-boggling to me. But they said if you get a large enough sample space, in other words, if you have enough people come through here and guess, that the number of people that overestimate, the number of people that underestimate will kind of level each other out. And the wisdom of the crowd, so to speak, is such that they're going to guess it. They're going to guess it right, get pretty daggone close every time. Isn't that neat? So if we had just asked enough people about my paper towel tearing. All right. Now look, we'll run through this one even if you're not finished just yet. But we're going to isolate the square root of r plus 4, right? So we add r, we subtract 2. So we got r, we got minus 2. That should be cake. That's the first step. Isolate the radical. If you mess that step up, everything else really isn't going to matter, okay? So don't be silly and make a careless mistake. We're going to square both sides. So the next step is going to be square both sides. So as I square the left side, I know that the radical and the exponent are going to cancel each other out. Whatever I do on the left, I got to do on the right, though. So I'm going to square the right side, and that's a FOIL problem, isn't it? Third or fourth time we talked about that. FOIL problem being here, I'm going to say r squared minus 4r plus 4. We ought to be able to FOIL in our heads. We ought to be able to do that at this point. Be able to square a binomial in your head. Remember the shortcut for that is square the first term, square the last term, and then double the product of those two terms. Okay? Subtracting r from both sides, we get minus 5r. Subtracting 4 from both sides, the 4's cancel out. So again, this is a quadratic equation. So we're going to factor the r, GCF, factor the r out. We got r minus 5 left over. Using the ZPP, I'm going to get an answer of 0, or I'm going to get an answer of 5. Again, ZPP just, at this point, I feel like I don't need to go through that process with you guys. We got 2 answers, but we want to check both of the answers. Which one is extraneous? You said that hesitatingly. Do you know that for a fact? Have y'all got that far yet? So when I plug in 0, 0 plus 4 is 4, square root of which is 2. 2 minus 0 plus 2 does not equal 0 on the right-hand side. Extraneous solution. We want to check 5 as well. 5 plus 4 is 9, square root of which is 3. 3 plus 2 is 5. 5 minus 5 does, in fact, equal 0. So the reason I say caution there is because the r equals 0 was an extraneous solution. Okay, pulled that up there so you guys could see it in the back. So r equals 5 was our solution there. Now, last example for today, and then I'm going to kick you guys on out of here, is when we're dealing with a radical that's not a square root. And I think James mentioned this earlier. What do I do to both sides once I isolate the radical? I raise it to the power of whatever the index is. In this case, the index being 3, I'm going to cube both sides. All right. So if I subtract 8, I got negative 4 equals cube root 5x plus 1. Now, do I need to throw on the brakes and say, hold on a second there, boss man. No solution. Radicals can't be negative. Jake, you're shaking your head. Why? Because it's a cube root. Roots of even degree are non-negative by definition, but cube roots, anything goes. The domain restrictions are done away with on a cube root function, right? Calderoni, what the heck you daggum doing in here? Huh? You thought early bird gets the worm. That a boy, I like it. Hey, we're going to cube both sides. What's negative 4 cubed? Negative 64. We got 5x plus 1. Okay? And then from there, that's a linear equation. We get one solution. All right, so subtract 1 divided by 5. There's my negative 13. And I want to check to make sure that makes sense. Negative 13 times 5 is negative 65, plus 1 is negative 64, cube root of which is negative 4. Negative 4 plus 8 equals positive 4. So that is a legit answer. I really like this section. This is a comfortable section. Like I said, it's a step-by-step process, very short, manageable 4 steps, okay? So look for some homework on Delta Math regarding solving basic equations that have radicals in them. Tomorrow, we will start dealing with some more challenging questions, some tougher questions, okay? Questions that involve exponential fractions in the exponents, rational exponents, and then we'll also start dealing with what do I do when there's 2 radicals in the problem, all right? So look online for Delta Math problems, a little bit of homework practice tonight, and live Jesus in our hearts. Awesome. Thank you, guys. Hope you all have a wonderful day.